Hi, my name's Nathaniel Garvin, and I'm a part of the Frebbins Parkinson's Foundation team. Over the coming weeks, we're hoping to bring you some interesting guests who can share with you insights into what's happening in the world of Parkinson's research. And this morning, I have a great pleasure of being joined by a researcher who spent 6 years at the German Research Center for Neurodegenerative Disease in Bonn, Germany, spent some time at the Department of Medical Neurology in Hebrew University of Jerusalem, and since March has been in a postdoctoral position here at the University of Tasmania, Menzies Institute of Medical Research. This morning I am joined by Ruth Musgrove. Good morning, Ruth.
Good morning. It's a pleasure to be here.
Thank you for joining us this morning, and let's kick off by talking about what is Parkinson's disease.
So Parkinson's disease is classified as a neurodegenerative condition, and that means that over the course of the disease, some of the nerve cells in your brains, or the neurons, actually begin to degenerate and to die. And these specific neurons that are affected by Parkinson's disease are really important in our ability to initiate and to control movements. Another really interesting thing that happens in Parkinson's disease, as well as this degeneration, is that we get the formation of these spherical things inside the nerve cells that are containing proteins and lipids. And we don't really understand where these Lewy bodies, we call them, and they're named after the guy that discovered them. We don't really understand where these are coming from, but we do know that they might be really important in some of the less obvious symptoms of the disease, which, I mean, specifically in Parkinson's disease, many of the patients complain of non-motor symptoms such as depression or changes in their sense of smell, changes in their ability to sleep or sleep disturbances throughout the night, or even changes in their gastrointestinal function. So we think that the Lewy bodies might be really important for these less obvious symptoms of Parkinson's disease.
What are the causes of Parkinson's disease?
So we don't really know what causes Parkinson's disease. We do know that age is the greatest risk factor, so most of the patients will develop the disease at or beyond the age of 60 or 65. In very rare instances, it can actually be inherited. This occurs in less than 10% of the cases, and generally if you inherit Parkinson's disease, you'll get it at a much younger age, but the progression of the disease will be much, much slower. In terms of environmental exposures, we do know that some pesticides and some solvents might increase your risk of Parkinson's disease, but we think that the disease is very complex and that it's actually a synergistic interaction or an addition of factors over your lifespan that might contribute ultimately to the disease.
I've heard, I don't know if you have the research on this, but as a side question, I've heard there's a higher incidence among doctors than the normal population.
Yeah, so this is actually a really interesting phenomenon. It's specifically in Australia, it's been noted, but we actually don't really understand this. There's no evidence so far to say that the disease is contagious, but it might be that the doctors are using certain solvents or substances in their day-to-day use, but we don't really understand the biology behind that association, but it's very interesting.
And that same potential issue with farmers, is that something you've come across as well? We've heard some feedback that it might be something to do with the higher incidence amongst farmers as well.
Yeah, so definitely we think that that's due to pesticides, and actually there's a specific pesticide that we've identified that can increase your risk of Parkinson's disease, and that's known as paraquat. It's actually banned in many places in the world, and in Australia we still use it, but it's very restricted. The use of paraquat is now very restricted.
Now, from the numbers I've seen, it says something like 80,000 people in Australia are impacted by Parkinson's. What is the economic burden of the disease?
I don't know the numbers off the top of my head, but I think it's close to $12 billion a year. It's quite substantial, the burden of Parkinson's disease in Australia, and particularly because it's an age-associated disease. We're aging population, we're living longer, it's becoming more and more prevalent in the population.
In terms of Parkinson's, what does it affect, and can it be prevented?
So it affects specific neurons in the brains, like I say, and we don't really know, as we don't know how the disease is caused. we don't think that it can be prevented, or we don't know how to prevent it. But what we do know is that generally healthy living, good exercise, a good diet will decrease your risk of getting Parkinson's disease. We also know that, and this is quite interesting, but smoking and coffee consumption can also significantly decrease your risk of Parkinson's disease. And we think that this is because these substances actually stimulate certain neurons in your brain. I'm not advocating for particularly for smoking, because you've got to weigh up the risk of Parkinson's disease with lung cancer, but definitely even if you develop Parkinson's disease and then take up smoking, it can actually really slow down the progression of the disease. It's a very interesting thing. So that's due to the nicotine in cigarettes.
That's an interesting one that I hadn't heard before. Are there any treatments apart from caffeine and nicotine available that can cure Parkinson's at the moment, or is that something still we're looking for?
We're still looking for a cure for Parkinson's disease, that's for sure, but we can effectively treat, at least for a short period of time, the motor dysfunction associated with the disease. So we can give patients levodopa, which really replaces dopamine in the brain. So when the neurons die in Parkinson's disease, those specific neurons can release dopamine, and dopamine is that substance that's really important for our ability to control movement. So we can effectively replace the dopamine in the brain. Another way that we can do this is a method called deep brain stimulation, and this is actually a surgical technique, so it's not really applicable to all Parkinson's disease patients, but some receive deep brain stimulation, and that's when an electrode is basically put deep into the brain, into a region of the brain called the thalamus, and it just triggers neuronal activity. And actually that can be quite effective in controlling the motor dysfunction associated with Parkinson's disease. Another thing that we have been doing actually since the early 80s or even the late 70s is using stem cells from human embryos and actually transplanting those cells back into the brain. And that also effectively replaces the dopamine. So those stem cells produce the dopamine and they release it into the brain. So the patients have enough dopamine to maintain normal movement. Nowadays, we're trying that therapy instead of with embryonic stem cells from humans. We're actually trying with the adult stem cells, so just cells derived from a healthy person's skin. We can redifferentiate these cells so that actually they're no longer skin cells, but they're the neurons that are dying in Parkinson's disease. So this is something that's actually we're working on now, and I think that it's a really promising thing for the future.
Yeah, fantastic. Is there any new medications on the horizon that you're aware of?
Yeah, so there are a couple. There are a few things going through clinical trial at the moment. So that means that we're actually testing substances in humans to see if they're safe and to see if they're actually effective. So before we get to this stage, we always do tests in animals, but these have proven effective in animal models of the disease. And we're currently looking at specifically something that's used already in humans to treat hypertension or high blood pressure. And actually, this agent works on those specific neurons also in the brain, and specifically those ones that degenerate in Parkinson's disease. So we think that using this hypertension medication, we can actually prevent those neurons from dying in Parkinson's disease. And this is the data from these studies will be released relatively soon. But the benefit of using already approved medication is obviously that we know that this drug is safe in humans and we know what doses to use. We are also really looking at another approach, which is a little bit like vaccination or stimulating either our own immune cells to recognize certain proteins that we think are really bad in Parkinson's disease and to degrade those proteins. So one of the proteins that we're looking at now is called alpha-synuclein, and that's one of the main components of those Lewy bodies that I was talking about earlier. And we think that actually alpha-synuclein, what happens in the disease is that it goes from being a very good protein to being a very bad protein. And that's associated with some structural changes. And we can identify the structure of the bad protein using our immune system is able to differentiate the good and the bad protein. So we're trying to target our own immune system or even insert antibodies that are already made to target these proteins and to degrade the bad proteins.
Wow, that sounds promising.
Yeah.
What do we still need to know about the disease in order to find and develop better treatments?
So I think because the disease is so complex and we don't really understand what's causing it, we might never know what are the very first events that occur in Parkinson's disease. But in a way, we don't really need to know this. But what we do need to know is that once the disease starts, how does it progress? How does the disease get worse within a neuron? How does the disease go from one neuron to the next neuron and from one brain region to the next brain region? And if we can really understand this process, I think we can really contain the disease to a very small population of nerve cells, and actually we can function quite well and without symptoms, hopefully. So if we can identify the disease in the very early stages and stop, or at least really, really slow the progression of the disease, then we can really improve the quality of life for people with Parkinson's disease. And I think that's what we're really heading for now, is to really understand how the disease progresses and what causes the disease to go from one brain region to another. And I think even if we can slow this process down, we can really improve the quality of life. And I think that that's the main thing that we're looking at the moment. We're also trying to understand exactly what is the role of these proteins that go from being a good protein to being a bad protein, and how this might be involved in the progression of the disease. And yeah, can we target specifically the proteins? Is that enough? Or do we need to target more things? So this is still things that we don't know.
Are there any other focuses of current research?
Yeah, actually, one of the main focuses of current research at the moment is diagnosing Parkinson's disease. So at the moment, we're actually diagnosing the disease in a really late stage when people already have so much loss of neurons and their quality of life is already quite poor. So what we're trying to do is actually identify ways in which we can diagnose the disease at a very early stage before the symptoms progress. And I think that that's really important if we want to inhibit the disease process and maintain that quality of life, that we need to be able to diagnose the disease as early as possible. And it's very difficult because it looks a lot like other diseases, and we need to be able to differentiate it. And I think this is one of the main challenges in research at the moment, is finding what we call a biomarker, so a marker in the body that's relatively accessible, such as blood or even your cerebral spinal fluid, that we can access and look at and determine whether people have Parkinson's disease or not. So that's one of the main focus, and other things that I've already mentioned, how the disease progresses, and also this idea of stem cell therapy and how that can be used to really alleviate those motor symptoms of the disease. So they're the main focuses of research at the moment.
Looking for those biomarkers, it strikes me from the what I've seen of Parkinson's so far that it almost seems like there's different types or something. Like it doesn't always present itself in the same way in every person. Is it likely that you'll find that the biomarker might appear for some in some cases in some way? And
Definitely for the genetic cases, the biomarkers are already there and it's already kind of easier in that respect. But the disease is also a little bit different between the genetic diseases and the other causes of the disease. So it might be that we have several different biomarkers of the disease, but in reality, it's very difficult to work in that kind of a system. We really need something that's a yes or a no to differentiate those people that have the disease from the general population. And I think that this is one of the real challenges, because we have identified biomarkers for Parkinson's disease. It's just that they're not robust enough to conclusively identify patients. And I think that this is one of the actual real challenges that we're facing at the moment.
Yeah, that makes a lot of sense. Is there anything else that people watching this would like that would be good for them to know before we finish up today?
I don't have anything in mind, but
Fantastic.
I think it's all good.
Yeah, brilliant. Well, thanks so much, Ruth, for your time this morning and for sharing with us a bit more about what's happening in the world of Parkinson's research. And if you'd like to watch this again, you can always find it on both in Facebook and also on YouTube. So thanks so much again, Ruth, and we'll catch up with you again soon.
All right, thank you.
Thank you.